Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 5-3 on concurrent lines, medians, and altitudes. We have lots to go over today and it can be quite confusing, so let's go ahead and get started. To begin with, we want to talk about something being concurrent or a point of concurrency. So whenever you have three or more lines that intersect in one point, those lines are called concurrent, and the point where they intersect is called the point of concurrency. So this is going to happen a lot in triangles. Before we get to that though, I want to briefly go over circumscribed versus inscribed for you. These words show a relationship between the circle and the triangle. So if you notice in the first one here, the circle is circumscribed around the triangle. And in the second one, the circle is inscribed inside of the triangle. So it makes a circle around the shape, that's called circumscribed. And if it's inside the shape, it's known as inscribed. So we're going to use both of those today. All right, there are many different points of concurrency within triangles, and the first one we're going to talk about is called a circumcenter. So the circumcenter of a triangle is the point of concurrency of the three perpendicular bisectors of the triangle. So remember, to bisect means to cut the side in half, and then a perpendicular bisector cuts the side in half at a right angle. So each side has its own perpendicular bisector, and those three lines will be concurrent. They'll have a point of concurrency, and that point is known as the circumcenter of the triangle. If you notice here, we have three different kinds of triangles, and what I want you to see is that in our first one here, our circumcenter is right in the middle of our triangle. In our second one here in red, our circumcenter is actually on the edge of the triangle. And in our last one down here, our circumcenter is actually outside of our triangle, and that's perfectly acceptable for a circumcenter. There is a theorem that goes along with the circumcenter, and what it basically says is that the circumcenter, remember it comes from perpendicular bisectors, but it's always equidistant from each of the three vertices of the triangle. And the reason for that is because if you circumscribe a circle around the triangle, each of the vertices here are on that circle, and the circumcenter is the center. So this is a radius away, and this is a radius away, and this is a radius away. So in this triangle here, AD is congruent to BD, which is congruent to CD. All right, so now we move on to an incenter. An incenter is the point of concurrency for angle bisectors. So if you cut each of the angles from the triangle into two pieces, you'll notice that number 3 and number 4 are going to be congruent here. Number 1 and number 2 are going to be congruent, and angle 5 and angle 6 are going to be congruent here. Those three lines will come together to form an incenter of this triangle. Now you might see this red circle inscribed inside of this triangle, and this incenter is the center of that inscribed circle. There's a theorem that goes along with this one as well, and what it says is that the incenter is equidistant from all of the sides. So if you start here at this incenter, you can go to any of the three sides on a perpendicular angle at a right angle, and they will all be the same distance. In this case, 1.9. All right, we move on to a couple of words. You may have heard them before. The first is called a median, and the second is called an altitude. We'll begin with a median. A median kind of sounds like the middle, and that's true. A median is a segment whose endpoint is a vertex, and it cuts the opposite side in half. So this median here starts at the vertex and comes across and cuts the left-hand side and the right-hand side into two equal pieces. An altitude, on the other hand, starts at a vertex and goes across to the opposite side, but it always goes at a right angle. An altitude always makes a right angle and is perpendicular to the segment that you just had. All right. So for the medians, if you have three medians of a triangle, that point of concurrency is known as the centroid. So notice how this side is cut into 2 equal pieces, and this side is cut into 2 equal pieces, and this side is cut into 2 equal pieces. So we know we're talking about medians, and that meeting point in the middle is called the centroid. And the centroid is kind of the balancing point for the triangle here. And it is important to note that each of these lines has a very special relationship. And that relationship is actually 2 to 1. The long side will always be twice the short side, and the short side will always be half of the long side. And that theorem here is our centroid theorem. So the median of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So DC here is 2/3 of the whole thing DJ. So CJ is 1/3 and DC is 2/3. And the same holds true for all 3 of these medians. And our last one today is called an orthocenter. An orthocenter is where all 3 of the altitudes of a triangle intersect. So remember, altitudes always come to the opposite side in a right angle, always. And those 3 altitudes will meet at a point called an orthocenter. And this one again shows you 3 different kinds of triangles because they want you to see down here at the bottom, if you have an obtuse triangle, your orthocenter will actually be outside of the triangle. And again, with an orthocenter, that is perfectly acceptable. All right, so these can be pretty difficult to remember which one's which. So I used the internet and found a kind of an easier way to remember them. And so we'll start up here on the top left. You have a colorful, pretty bird. So the circumcenter is found with perpendicular bisectors. The circumcenter with perpendicular bisectors, a colorful, pretty bird. The incenter with angle bisectors, I am beautiful. Incenter, angle bisectors. Down here on the bottom left, we have a crazy monkey for the centroid and medians. And then our last one over here on the bottom right is an orange apple, orthocenter and altitudes, orange apple. I hope this helps you guys. Good luck, everybody. Have a great day.